Welcome to PCB Design Fundamental course. In this lesson, we will dive in the world of printed circuit board and uncover their significance in the field of electronics. Printed circuit boards are the backbone of electronic device. They provide a physical platform for connecting electronic components such as resistors, capacitors, LEDs, and ICs. Knowing how PCB work and how to design them is essential for anyone who wants to create or understand the electronic circuit. In this chapter, we'll introduce the concept of PCB, their function, and their composition. But before we get into PCBs, let's take a look how electronic components were connected before PCBs were invented. Imagine a simple diagram of connecting one LED to 12 volts battery. Initially, one might think of connecting them directly or using wires and soldering. This method is known as point-to-point wiring. This method is easy and correct for a simple circuit with a few components. But what if we have a circuit with large number of components, or if we connect 12 LEDs instead of one in our previous example? Then we would need many connections and a lot of soldering. This would make circuit messy, bulky, and hard to troubleshoot. It would also increase the chance of failure, such as short circuit or lost connection. That's where PCB come in handy. PCB replaced wire with copper tracks that's actually on a flat board made of insulating material. The tracks act as a conductor that connects the component on the board. The components are mounted on the board and soldered to the tracks. This way, we can create complex circuit with many components without using any wire. We'll explain how PCB are made and how to design them in later lessons. Another notable technique worth mentioning is wire wrap. This technique involves tightly wrapping wire around the nuts or terminal of electronic components such as integrated circuit or electronics connector. Wire wrap was popular in 1960s and 1970s, but now is primarily used in prototyping to enable flexibility, circuit modification, facility debugging, and allow for component reusability. That's all for today's lesson. In the next lesson, we'll discuss different types of PCB based on their flexibility. Don't forget to test your understanding by taking the short quiz that you can find in the link below. See you in the next lesson.